All right, so let's talk about the software development life cycle. As the name suggests, the software, every line of code that you write, any file, any piece of source file that you write goes through a life cycle, right? Ideally, having been presumably it was created in a context, in some context. It was ideally is because somebody needed to solve some problem, and your file, your source code is solving that problem, some requirements, right? So typically, if you're working for someone in a company, a large corporation, you are working within a context, right? It is and usually you'll be working on files that have existed already. Usually in something that is legacy, so that somebody else wrote. It's unlikely, but if you have a chance to work on a brand pristine project, that's great. But more commonly, you'll be working on code that has been around for a while, and so it has a lifespan. Okay, so the thing to understand is that you are jumping in the middle of a long-running story. Okay, it's like opening a book in the middle of it, and you're trying to make sense of how do we get here, where am I, and where are we going? Okay, so life has its life cycle. From inception, it goes through development, design, development, testing, deployment, maintenance, right? And as we saw earlier, the process that we have been using to manage the life cycle of software, has been a failure, right? We have a very bad track record at managing the life cycle of software and having it be a successful project. Okay, so we're gonna cover some of the historic milestones. Our industry is a fairly young industry, and we're still trying to understand what methodologies work and which don't. We've been trying all different things. Lately we've been trying this idea of being agile, really lean and whatnot, and it's just the latest incarnation of multiple ideas that we've been trying out for years. Yes. And it's a story in progress. Okay, it might be that by the time you graduate and you go out and work, it might have evolved already. Okay, or perhaps once you are part of the workforce, you will come up with the next generation of methodologies. Yes, but ideally you want to see what other folks have tried, right? What has worked well, what hasn't. Why did it evolve one way or another? What were they trying to do? And perhaps propose new ways of doing things. Okay, so certainly we're not at the end. Certainly we're perhaps just at the beginning. We're just trying to understand how is it that we should best develop software. Right, understanding what are the limitations. Right, what are the constraints. Certainly we don't have infinite amount of time. We don't have infinite amount of money. Right, so within those constraints. What can we build that has a certain level of quality, right? That is solving something and is giving value to the end user. All these techniques are basically techniques that are all trying to manage chaos. Right? They're all trying to manage complexity. Usually, these projects that are going to be working on, they're so big that no one person can understand them on their own. And they can nowhere they can tackle it on their own. They have to collaborate with other users. Communication is hard. We can all agree on something today. We come back tomorrow, and it turns out that we thought we knew what we had understood, and it turns out that we didn't understand. Right? So it's very, very hard, and we understand why. Why is it so hard? So let's take some of the different things. Different members of the team. What kind of things can you change? What is under your purview, right? If you're on the tech side, you might get to choose the technology stack, right? Let's use Angular, or let's just use React, or Node, or NoSQL, or whatnot. You might also choose the processes by which you are going to develop, right? You might also get to hire the people that you want to interview, dozens of folks, and not find them and having to go on and find them, right? If you're on the client side, they have the money. Are they willing to invest and risk their money with only a 30% chance of success? Are they going to feel comfortable with that? Another 30-40% of being so-so and having to spend maybe twice as much as they thought they were going to spend to get something more or less what they wanted, or maybe another 20-30% of being a total failure, right? So they have the money. They want, presumably they have an idea of the functionality that they want, the behavior that they want. Perhaps they have a time frame, based on competition and when they want to go into market. And so with all these moving parts, and this is important, everything is moving, right? Everything is moving, right? If we should never feel complacent that things are kind of static, that things are comfortable. Our industry just moves at a huge amount of speed. Okay, so just be cognizant that everything is moving. Requirements are moving. Folks are moving. Folks are coming and going, and so it takes a team. It takes a large team to deal with this. There's tons and tons of documentation. There's knowledge transfer. There's and requirements are changing. The tools are changing, and we need to turn over this to some other team perhaps, and we have to integrate with other folks are doing. So everything's in motion. Everything is people come and go. The project grows and shrinks. So we fail to understand how the scale affects this, right? Something that we thought was going to be simple, that we can prove that works for a dozen folks, turns out that when you consider thousands or hundreds of thousands, it just breaks, right? And things, things tend to be NP complete, right? We tend to think in a linear sense, and when we find out that things turn to be exponential, that they work for small numbers, but when you talk about huge amounts of numbers, it's a completely different factor. Right, you probably will have to deal with somebody else's source code, right? That has been around for quite a while. Most of us don't enjoy having to manipulate or work with somebody else's code. There's obviously a barrier of trying to understand what other folks were thinking, and you're understanding that you're just one knob, one cog in a much larger machine, right? And ideally you make an effort to see, right, and be an introspective and see, how is it that you fit in this larger machinery, right? And understand what the project is, what the overall business is, right? So yes, it's a process, and we'd like to be able to be measured or be identified as our project being effective, being efficient, being relevant, manageable, reusable, all these intangibles, right? Of how we would love to be thought of. So the software development life cycle is different techniques and strategies that allow us to manage the process of how software comes to inception, gets designed, developed, deployed, maintained. So some of the key steps in the software development cycle is feasibility. Can we even build this? Do we even have the technology to build this? Do we have the inner knowledge to build this? Do we have the specification? Have we already met with the client? Have they specified exactly what they want? Usually that's one of the hardest parts. Agreeing, coming to a consensus. What are we building? The second hardest thing is, what are we going to do first? What are the priorities? Should we do this first or that first? So those two things are one of the most challenging things in the project. Agreeing on what we're going to do, and when are we going to do them? Right? Those are very, very hard, especially when you have requirements moving, budgets moving. Ideally, you would like to identify the highest priority so we can tackle that first. right? So that if we lose the budget, well, at least we did the most important things is there, right? The core functionality is there. Then, so specification, then choosing an architecture, a technology stack, designing, creating documented class diagrams. Then it goes into a development phase, then a validation and see if it's acceptable to the end user, and then evolves in maintenance. Oftentimes it's a mess, right? We promise a nice, a smooth ride, and it turns out to be oftentimes it turns out to be a much harsher reality. All right, so process. So all throughout our young industry, we have tried different things. All right, how do we manage large projects where we have lots of folks working, everybody with their own points of view, everybody with their own biases, everyone with their own agenda? How is it that we come to consensus? So it used to be that it was fairly simple. Everybody just got to start working on this. We would build the first version, we would present it, we'd demo it, see what the difference was between what we delivered from what the client actually wanted, and that difference we tried to fill in that gap, right? Up until we would iterate until ideally we got closer and closer to what the client wanted, and they were satisfied. It was operated, and at some point it was retired. And we're not very far from this in current processes. They're fairly similar. Some of the caveats of this is that there was no separation of concern. Kind of everybody did everything. Today we have a more well-defined types of architecture, right? We have identified certain skills that we need for different types of problems. So you can have a whole career on the back end, right? And databases and data layer and multi-threaded environments and whatnot. You could do an entire career there, right? And those have a particular set of concerns, right? Or you can do an entire career on just in the front end, right? Making things look pretty and HTML and CSS and Photoshop. Or somewhere in between, right? Middle tier and whatnot. Each one with its own types of concerns. Yes? Back then, the systems were small. Everybody kind of did everything, right? As the systems have evolved and grown bigger and bigger, we have had to specialize, right, on particular aspects and concerns of the architecture. And also because, again, the whole idea here is that no one person can do everything. And there was no way to deal with complexity. Now we know that we need to break it up. We have to come up with different layers. That your layer will talk to my layer. We'll come up with an interface, right? And we'll be able to interact with those. And that's how we deal with complexity. Code and fix. It's coding horror. So one of the earlier ideas of how to deal with complexity and deal with larger projects is referred to as the waterfall model, which worked well in domains that were very well understood. Right? If somebody understood what the problem was and what the business was, if it was a mature enterprise, waterfall worked pretty well. Okay. And also if requirements didn't change much, and if there was not such demand from the users or from the competition, waterfall worked quite well. Okay, today waterfall perhaps is not as effective. Ever since our architecture of deploying software has changed dramatically, right? Early on, again in the 50s, you might have mainframes, right? And software was deployed in one single place, and everybody had like these dumb terminals. Now updating the software was fairly simple. There was only one place to maintain it, and then everybody else got the updates because the terminals were just interacting with this mainframe. Yes. So deploying and maintaining it had its own techniques. Once personal computers came along, now we had these powerful machines sitting on our desk. The distribution of software changed dramatically. right? And it was very easy for us to have different versions and incompatibilities, and it was a pain, right, to upgrade. We've kind of come back all round circles back to the mainframe, right, where we have centralized servers and we have these browsers as these dumb terminals that are interacting with these central machines, right? The deployment of software, again, has come back to being a very easy way to deploy. You just deploy to a server, and everybody gets the latest version, immediately when they navigate to their browsers. Also, the update of these changes has become much easier, and the competition has been increased very much, and will continue next time. All right, thank you.